Hello students, welcome to the second lecture on the lecture series on probability. So previously we have covered all the type of basic concepts and theories that are usually covered in the topic probability in various competitive exams. So in this lecture what we will do is, in order to sharpen all those concepts and to get a better grip at those concepts, we'll do some exercise problems, right? Because exercise, doing more exercise will actually give you more confidence in exam. Okay, so let's start this lecture and do some exercise problems. So in this lecture we'll be covering exercise problems. So let's start with problem number 1. So suppose that each child born is equally likely to be a boy or a girl. Okay, so if a child is born, then there is only two options, right? One is either it is a boy or it is a girl. Okay, so these are the only two options. Okay, this is option 1, this is option 2. So consider a family with exactly 3 children. Okay, so you have a family, so you have basically a father, a mother, and what they have is they have 3 children. Okay, so you, as you know, if a child is born, it has what, two kind of choice, that is either it is a boy or a girl. Okay, so this can be a boy or a girl, this can also be a boy or a girl, this can also be a boy or a girl. Okay, so consider a family with exactly 3 children. So we have considered a family where there is a father, there is a mother, and there are 3 children there. Okay, so what it wants to do is, it wants that list the 8 elements in the sample space, okay, whose outcomes are all possible genders of the 3 children. Okay, so we want to what, create the sample space. So sample space, let's try to create the sample space. So sample space will be what, either the first one is a boy, second one is a boy, and third one is a boy, right? This, or first one, second one is boy, third one is girl, right? And then what we can also say, either it is a boy, then a girl, and a boy, right? So let's try to see the other options. Okay, so then what can happen is, the first one is girl, then the boy, then the boy. Okay, here the sequence represents what, this represents that it is born first, this is born second, this is born third. That is why the sequencing is important, and that is how these three are actually different, all different, right? So let's try to see when there are two girls. Okay, so let's say we have first one is boy, then we have a girl, and then we have a girl, right? So there are two girls. So the case of having more than one girl starts from here. Okay, so then we can see that if we have what, a girl, then a boy, then a girl, we can also have a girl, then a boy, right? And what can we have? We can also have a girl, girl, and girl. Okay, I guess these are the only options. So one, so this is the first option, second, third, four, five, six, seven, and eight. So as you can see here, we have a sample space with 8 elements. Okay, so the elements are as follows: BBB, BBG, BGB, GBB, BGG, GBG, GBG, GGB, and GGG. Okay, so these are the sample space elements. Okay, so basically we have completed option number 1, where we had to list 8 elements, okay, in the sample space whose outcomes are all possible genders of the 3 children, right? So option B, write each of the following events as a set and find its probability. Okay, so what we have to do right now is, we have to write each of the following events. Okay, so this is event number 1, event number 2, event number 3. Okay, and we need to find their what, probability. Okay, so the event that exactly one girl is a child. So as you can see here, let me remove these ones. Okay, the number of what, sample space elements. Okay, so we have removed the indexing. So let's see. So the event that exactly one child is a girl. So you know that probability of a event, let it be u1. Okay, let this event be u1, this be e2, and let this be e3, right? So probability of e1 will be what? So probability of e1 is nothing but what, cardinality of e1. So how many elements do the set e1 have? Okay, by total cardinality, that is cardinality of the sample space. Okay, So as you can see here, so the event is what? Exactly one child is girl. So can you see in this case that one child is girl? No, right? Here, yes. Here, yes. Here, yes. Here, no. Why? Because there are two girl child. And what we want is we want only exactly one child is a girl. Here is also not possible. Here is not possible because there are two girls involved here and here is three. So it can't be also a case. So the only three cases are these. That is boy, girl, boy, and girl, boy. Okay. So only three. So this will be equal to what? So this will be equal to 3 by 8. So this is the probability of E1. So let's try to see probability of E2. So the event that at least two children are girls. Okay. So let's try to see. For this, it will be the same. Probability of E2 will be what? E2 cardinality, right? Cardinality of E2. So cardinality of E2 by cardinality of the sample space. What it will be equal to? So let's see the case. That is the event that at least two children are girl. So basically, we can have two children as girl, and we can also have three children as girls. Okay. So let's see. Can this be an option? No. Can this be? No. Can this be? No. Can this be? No. But here we can have, right? So this is a option that is eligible for E2, right? So this is also eligible because there are two girl children. This is also eligible as there are two girl children. This is also eligible. Why? Because here are more than two girls here. Okay, that is three girls here. That is actually more than two. So that is also at least two children are girls. That is what the condition tells us. So here, since at least two are there, okay, in every possible scenario, so it will also be included. So basically, we have 1, 2, 3, and 4. 4. Okay, these four elements belong to E2. So it will be equal to what? 4 by 8. That will be equal to 1 by 2. So there is actually 50% probability or 0.5 as probability that at least two children are girls. Okay, so let's try to see the next case, that is the E3, right? So let's try to see what E3 actually wants us to do. So the event that no child is a girl. Okay, so let's see in which case actually there is no girl involved. Okay, so let's start from the end. So here three girls are involved, so this can't be the case. Here two girls are involved, this can't be the case. Two girls, this can't be the case. Also two girls, this can't be the case. One girl, can't be the case. Okay, and one girl is here, so this also can't be a case. But here only no girls are here, so this can also be a case. So what will be the cardinality of E3? Since only B, that is boy, will be inside E3. Okay, will only belong to E3. So that is why probability of E3 will actually be equal to cardinality of E3, right? By what? Sample space cardinality. So it will be equal to 1 by 8. So this will be the probability of E3 case. Okay. So by doing all this, we have solved problem number 1. So let's try to see the step-by-step solution. Okay. So all possible genders are what? Boy, girl, boy, girl, boy, girl, girl, boy, girl, boy, girl, boy, girl, and girl. Okay. In the sequence of their birth. Okay. So let's try to see. So the first case is denoted as what? A event. Okay, so only exactly one girl child is there. Okay, so only these three this condition will what? Filter out what? 5 from the 8 of the list. Okay, so only 3 will be there. That is boy, girl, boy, girl, boy. So probability of A will be 3 by 8. And in a similar way, what? By at least two children are girl, this condition, what we can do is we can filter out 4 options from all the 8 options in the sample space. So what we are left with is only 4 cases, that is girl, boy, girl, and boy, girl, and girl, girl. So probability of B will be equal to 4 by 8. So let's try to see third case, that is let's see denote the event, that is no child is a girl. Okay, so the only possible option for this is boy, and boy. Okay, so probability of C case will be 1 by 8. That is the reasoning. Let's start with problem number 2. Okay, so 4 candidates A, B, C, D have applied for the assignment to coach a school cricket team. Okay, so there are basically 4 teachers, okay, who want to be the coach of a school cricket team. Okay, so if A is twice likely as to be selected, okay, as B, Okay, let probability of B will be x. Then probability of A is equal to what? 2x as given right here, because if A is twice as likely to be selected as B, and B and C are given about the same chance of being selected. So this is equal to what? Probability of C. Okay, so let it be also x. Okay, while C is twice likely to be selected as D. Okay, so let probability of D is equal to 2y. Probability of D is equal to y. So this implies that probability of C is equal to 2y. This is what given to us, because what? Well, C is twice as likely to be selected as D. Okay, so this implies we can say that probability of B will be equal to what? X, that is equal to y, so it will be 2y. So this implies that probability of A will be equal to what? 2 into 2y, so it will be 4y. Okay, so as we know, the probability or the sum of all the probability of all three exclusive events must be equal to what? Or elementary events must be equal to 1. So this implies that probability of D plus probability of C plus probability of B plus probability of A. Okay, if we add all these, this should be equal to 1. So let's see. So it will be what? Y plus 2y plus 2y plus 4y. So what it is equal to? So 6y, 7, 8 and 9y. 9y is equal to 1. So this implies that y is equal to 1 by 9. Okay, so we can write as y is equal to 1 by 9. Okay, so what are the possibility that C will be selected? So C will be what? 2y. So probability of C will be equal to 1 by 9 into 2. That will be equal to what? 2 by 9. So what is the probability that A will not be selected? Let's try to see first probability of A. That is A will be selected. Okay, it will be 4y. So 4 by 9, right? So probability of A complement will be what? Is equal to, that is A will not be selected. It will be equal to 1 minus probability of A. Okay, using the theorem from what? The theory lecture, we can write this. So this will be equal to 1 minus probability of A. So probability of A is what? 4 by 9. So this will be equal to 5 by 9. So the probability that A will actually not be selected is equal to what? It will be equal to 5 by 9. And what is the probability that C will be selected? This is equal to probability of C, that is equal to 2y. So it will be equal to 2 by 9. Okay, here. So let's go forward and see the step-by-step solution. Okay, so given that P of A, probability of A is actually twice of probability of B. So probability of A is equal to 2 into probability of B. We can write this. So probability of B is approximately equal to what? Probability of C. So this is what we can conclude. So probability of C is what? Is actually twice of probability of D. So probability of C is equal to 2 into probability of D. So using the above information, what we can say is we can actually set up the following equations. So what are those equations? So the equation is as follows. Okay, since these are mutually exclusive and actually independent events, and what these are is actually these actually complete the whole sample space. Okay, so their sum must be actually equal to 1, right? So since the total probability is 1, so from the given what, this is what we are given, these are the conditions that were given to us, right? So from second I, probability of B is equal to what? 0.5 into probability of A. So from IB we can write that probability of D is equal to 0.5 into probability of C. So probability of D is equal to 0.25 probability of A. Okay, so probability of A will be equal to what? 1 by 2.25, that is equal to 4 by 9. Because what? If we substitute those values into I, probability of A plus 0.5 into probability of A plus 0.5 into probability of A plus 0.25 into probability of A. So probability of A will be actually equal to 4 by 9. The probability of B will be equal to what? 2 by 9, because 0.5 into 4 by 9 is nothing but 2 by 9. So probability of C is equal to probability of B will be 2 by 9. Probability of D will be 1 by 9. So the answers are, the probability that C will be actually selected is 2 by 9. Probability of C is equal to 2 by 9, and the probability that A will not be selected is equal to what? 1 minus probability of A is equal to 1 minus 4 by 9 is equal to 5 by 9. Let's try to see problem number 3. So how many 2-digit positive integers are multiples of 3? And what is the probability that a randomly chosen 2-digit positive integer is a multiple of 3? Okay, so basically what we have here is how many 2-digit positive integers are multiples of 3, that we want to calculate. Okay, so basically we have a 2-digit number, okay, where x is actually not equal to 0. Okay, so we want to calculate how many possibilities are there such that the 2-digit positive numbers integers are multiples of 3, and what is the probability that randomly chosen 2-digit positive integer is a multiple of 3. Okay, so probability of E is what? Cardinality of E by sample space. So we want to calculate first what is the cardinality of E. Then the sample space is what? The how many numbers can be 2-digit number. So 10 choices are for the second. If this is a 2-digit number, 10 choices are for this number, that is unit digit, and 9 choices are for this. Okay, that is 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 into 10 is equal to 90 options are there. So let's see the step-by-step solution. So 2-digit positive integers which are multiples of 3 are 12, 15, 18 and 99. So there are actually 30 such integers. Okay. So 2-digit positive integers are what? 10, 11, 12 up to 99. So there are 90 such numbers, right? Since out of these only 30 numbers are multiples of 3, therefore the probability that a randomly chosen positive two-digit positive integer is actually a multiple of 3 is what? 30 by 90, because probability of E is equal to what? Cardinality of E by total cardinality of the sample space, that will be equal to 30 whole by 90, that will be equal to 1 by 3. Okay, so let's see problem number 4. So a typical PIN, personal identification number, is a sequence of any 4 symbols chosen from 26 letters in an alphabet and the 10 digits. So if all pins are equally likely, what is the probability that a randomly chosen pin contains a repeated symbol? Okay, so pin is a sequence of 4 symbols selected from 36, that is equal to 26 letters, 10 digit symbols. Okay, so by the fundamental principle of counting, there are 36 into 36 into 36 into 36, that is 364. So 1679616 pins in all. Okay, these are the all number of pins that can be possible. Okay, so when the repetition is not actually allowed, then the multiplication rule can be applied to conclude that there are what 36 into 35 into 34 into 33, because repetition isn't allowed. Since we have chosen one, we have to exclude it from the whole number that we multiply with it. So doing the same, we are left with 1413720 different pins. So the number of pins that actually contain at least one repeated symbol is what? 1679 1616 minus 1413720. So this is equal to what? 265896. So the probability that a randomly chosen pin contains a repeated symbol is what? 2,65,896 whole divided by 16,79,616. That is actually equal to 0.1583. Let's see problem number 5. Right. So an experiment has 4 possible outcomes A, B, C, and D that are mutually exclusive. So explain why the following assignments of probabilities are not permissible. So probability of A is equal to 0.12, probability of B is equal to 0.63, probability of C is equal to 0.45, probability of D is equal to minus 0.20. So probability of A will be equal to what? 9 by 120. Probability of B is equal to what? 45 by 120. Probability of C is equal to what? 27 by 120. Probability of D is equal to 46 by 120. So since probability of D is equal to what? 0.20 minus 0.20, this is not possible as the probability must lie between 0 to 1. So for any event. So probability of S is equal to probability of A union, probability of B union, probability of D union, C union D, right? So it will be 9 by 120, 45 by 120, 27 by 120 plus 46 by 120 added all together. So that is equal to 127 by 120, that is actually greater than 1. So this violates the condition that probability of S is equal to 1. Let's see probability 6, problem number 6. So probability that a truck stopped at a roadblock will have 40 brakes or badly worn tires are 0.23 and 0.24 respectively. Also, the probability is 0.38 that truck stopped at the roadblock will have faulty brakes and badly working tires. Okay, so here we are talking about the intersection. So both of these are happening. Okay, what is the probability that truck stopped at the roadblock will have faulty brakes as well as badly worn tires? Okay, here it is not and, this is only or. Okay, here we are asking about and. Okay, so let B be the event that the truck stopped at the roadblock will have faulty brakes, and T be the event that it will have badly on tires. Probability of B is given, T is given, probability of B union T is also given to us, right? So it asks us probability of B union T. So we'll be actually using this formula. Probability of B union T is equal to probability of B plus probability of T minus probability of B intersection T. So that's because B union T is actually equal to B union T. Okay, cardinality of this will be equal to minus probability of B intersection T. Otherwise, it will be repeated twice. So probability of B plus probability of T minus probability of B intersection T. So it will be equal to 0.30 is equal to 0.23 plus 0.24 minus probability of B intersection T. It will be 0.09. Okay. So let's try to see problem number 7. If a person visits his dentist, suppose that the probability he will have his teeth cleaned is this much, and the probability that he will have his cavity filled is this much. The probability that he will have a tooth extracted is 0.20. The probability that he will have a teeth clean and cavity filled is this much. So the probability that he will have his tooth clean and extracted is this. The probability of that he will have a cavity filled with a tooth extracted is this much, and the probability that he will have his teeth cleaned and cavity filled and a tooth extracted is 0.03. What is the probability that person visiting the dentist will have at least one of these things done before him or done to him? So let's try to see. Probability of C is equal to what? 0.48. Probability of F is equal to 0.25. Probability of E is equal to 0.20. Because what? C is the event that the person will have his teeth cleaned. Okay, that is why we have denoted it as C. And for F and E to have event of getting cavity filled or tooth extracted. For cavity filled it is F. For tooth extracted it is E. Probability of C intersection E is equal to 0.12. Probability of E intersection F is equal to 0.07. Probability of C intersection F intersection E is equal to 0.03. So now what? Probability of C union F union E is equal to probability of C plus probability of F plus probability of E minus probability of C intersection F, probability of C intersection E minus probability of F intersection E plus probability of C intersection F intersection E. So it will be equal to 0.48 plus 0.25 plus 0.20 plus 0. Minus 0.09 minus 0.12 minus 0.07 plus 0.03 is equal to 0.68. Okay. So let's try to see the problem number 8. So an un contains 20 white strips paper numbered from 1 to 20. So red slips paper numbered from 1 to 10. Okay, so 40 yellow slips paper numbered from 1 to 40, and then 10 blue paper numbered from 1 to 10. So these 80 slips paper are thoroughly shuffled, and that each slip has the same probability of being drawn. Okay, so what we want to find? We want to find the probability of drawing a slip of paper that is blue or white, numbered 1, 2, 3, 4, 5, red or yellow, and number 1, 2, 3 or 4, numbered 5, 15, 25 or 35, white and number higher than 12, or yellow and number higher than 26. So blue or white, it will be what? 10 by 80 plus 20 by 80 equal to 30 by 80 or 3 by 8. So P numbered 1, 2, 3, 4 or 5. So it will be equal to what? Of any color will be 4 by 80, 4 by 80, 4 by 80. It will be 1 by 4. Actually, this will be greater, right? Because 2 by 80 is equal to 1 by 4. And here we have got 3 by 8. So this is actually the efficient and correct way. Okay. So I believe that's enough for today. So thank you.